Good afternoon, friends. Now, myself, Dr. Kushal Bhattacharya. Today, I should discuss and very important topics which always goes in your mind while buying a car, or this important, very simple knowledge is required. What is the difference between a normal aspirated engine and turbocharged engine? So this is a very basic thing. What is the requirement on basis of which you should buy a turbocharged engine, and what is the requirement on basis of which you should buy a normal aspirated engine, and basically what is the difference between this? So I thought of discussing a few things on this. So let us start with the discussions. Now, before understanding what is a normal aspirated engine, we have to understand the four strokes. We have to understand the four strokes which happens to an engine. So first, we have to see this is an inline cylinder of a four-cylinder engine. This is an inline. This diagram consists of an inline four-cylinder engine, where you could see this is the cylinder 1, this is cylinder 2, cylinder 3, cylinder 4. Now here, this thing is called the piston, which has got a piston ring. There are three piston ring are there. So this the three piston rings are provided, and over here connected the crankshaft, and attached with the crankshaft is the flywheel. So the pistons move up and down, and what happened? Power is produced. Now basically what happens? Here the pictorial view of what has been discussed in the board has been shown. It is a 3D view. The piston connected with the crankshaft, and the crankshaft is ultimately connected with the flywheel. And as the flywheel rotates, the crankshaft moves, the piston moves up and down with the help of the crankshaft and the connecting rod. So there is an inlet valve. This is an exhaust valve through where the exhaust gases will go, and this is the spark. So basically, what happens? The first one is the suction stroke. So in suction, what happens? The piston moves down. That is, there are two levels. There are two things. Level by which the piston operates. The first one is if it is for a vertical engine, it's called the upper dead center, and the lower one is called as the lower dead center. For horizontal engine, if the engine is running in a horizontal direction, then it should be inner dead center, and the counterpart should be outer dead center. So now what happens when a piston moves down? When a piston moves down from the upper dead center to lower dead center, what happens? Air gap is created, because an air cavity is created. So to fill up the air cavity, what happens? The inlet valve opens. Now for a petrol engine, petrol mixed with air, this mixture can be done either by a carburetor in a primitive engines, or in modern engines it can be also done by an MPFI. So normally the stoichiometric ratio is 16:1, that is 16 part of petrol, 16 part by volume of air and 1 part by volume of petrol should be there. Okay, so this 16 part by volume of air and 1 part by volume of petrol should be there. So as we have discussing about the petrol engine, so what happened? So this petrol mixed air enters into the system during the suction stroke. So because if you see in the torque theta diagram, this is the torque theta diagram. This if you see, this is called the torque. This y-axis is called the torque given in Newton meter. This is called the torque, and the x-axis is called the crankshaft given in angle theta. So what happened in the torque theta? What happened when the piston moves through 0 to 180 degree? That is, when the flywheel basically moves from 0 to 180 degree. What happened? The piston comes down and the suction takes place. That is, no work has been done by the system. So this is the condition when no work has been done by the system. Now what happens during the compression stroke? Basically what happens? The piston moves upwards. So when the piston moves upwards, the inlet valve is closed, and the exhaust valve is also closed. This is controlled. The inlet valve and the exhaust valve is controlled by a cam mechanism. So I should not discuss right now in this lecture. So this is again operated with the help of the engine. So I will not discuss right now. So now what happened when the piston moves upward? Both the inlet valve and the outlet valves are closed. So when the inlet valve and the outlet valves are closed, so what happened? as the piston moves up, and the air fuel mixture is compressed reversible adiabatically. The air fuel mixture is compressed reversible adiabatically. So what happened, as it compressed reversible adiabatically, what happened, its temperature increases. So as it compresses, its volume decreases, and as its volume decreases, its temperature increases. Now as the temperature of the air fuel mixture increases, there is a temperature for every volatile substance where it catches fire. So it reaches as we are reducing the volume, what happened, the temperature go on increasing, and the flash point, as I discussed just now, for every volatile substance there is a temperature at which it catches fire, that is called the flash point. So as the piston is compressed, what happens in this condition, this temperature is increased, and at that time what happened, the petrol reaches the flash point. And at that exact moment, a spark is generated from the spark plug. Then what happens, the air fuel mixture starts burning. So during the compression stroke also, there is no useful work is done. Now as the air burning starts, what happens, it gives a huge thrust to the engine. And now this thrust is a useful power obtained by the gas. So what happens, the torque, what happened, basically that this work has been done by the system, so we'll get a huge rise in torque. So this is the effective torque of the force effective stroke. So now what happens, the power increases to a very high, and after that what happened, the last stroke which is called the exhaust stroke. What happened, the inlet valve remains closed, and the burnt air fuel mixture goes out of the cylinder. This is basically how a normal aspirated engine works. Here a pictorial view of the four strokes has been shown. So figure 1 suction, figure 2 compression, figure 3 power, and figure 4 exhaust. Here the red color shows the movement, up and down movement of the piston, and the rotating red color shows the movement of the crankshaft. So when the crankshaft moves, what happened, it also shows the movement of the valves. So you just follow this diagram which has been explained previously. So now another thing, if you go for the cycle also, auto cycle, if you see the auto cycle, you also see that if you go the PV diagram also, you see when the compression takes place, there is a sharp rise in pressure, and there is a sharp decrease in volume. So in this region, what happened, compression takes place. So at this condition, when the compression takes place, we gives a spark to it. That means heat is transferred to the system, and it catches fire, and what happened, a huge amount of heat is generated. So huge heat is generated at constant volume. So this point is called a constant volume heat addition. So this cycle for a petrol cycle, that's reason also called a constant volume cycle, and the constant volume heat addition cycle. And this cycle is called as an auto cycle. What happened, that the pressure rises to a very high point. Now at this pressure, what happened, gives a huge thrust to the piston, and the piston moves down. And as the piston moves down, what happens, reversible work is done by the cylinder. It has been done on the cylinder. Reversible, that means the piston moves down, and a huge amount of work has been done by the gas on the system. So what happens, on the system, and it moves like this, and 3 to 4 the work has been done, and 4 to 1 the exhaust stroke, and 4 to 1 the heat rejection, which is basically called the exhaust stroke. Now this is all about a normal aspirated engine. Now we have to know why, what is the use of then supercharged engine, and what is the essence of a turbocharged engine. Now if you see that if more air fuel mixture can be pushed inside the cylinder, what happens, its volumetric efficiency will increase. That is what, that is given by M into V into P into D. So that is PD is equals to the distance covered by the piston from the upper dead center to the lower dead center into its cross-sectional area. That is pi by 4 d square. Pi by 4 d square into this area is the volume. So now what happens? This is the displacement volume. So this is the displacement volume served by the piston. Now in this displacement volume, the normal aspirated engine, what happens due to atmospheric pressure? What amount of volume? M dot is the mass flow rate of air, and V1 is the specific volume of that mass of the mixture. mixture. M dot is the mass flow rate of the mixture, and V1 is the specific volume of the mixture. Now what happened at that condition? If you could supply more and more mass, so what happens? Volumetric efficiency will increase, and ultimately we will get more power. So So for that reason, what is done? What can be done? So for that reason, what can be done? The first scientists discover what is called a supercharger. Now what supercharger does, the supercharger does is basically it uses a compressor taking power from the engine, so it compresses the air and sends more air than the normal air pressure. So it supplies more air than the normal air pressure. So what happens? So it gets more air than the normal air pressure. But the problem here arises that its volumetric efficiency is increased, no problem. But the thing is that as the compressor is compressing the more and more air to the inlet, what happens? Its power ultimately drops because it is taking power from the engine itself. So for this reason, the supercharger is not used. Basically it is used primitively, but supercharger is not used because what happens? Its efficiency decreases. And and although still as it consumes power from the engine, but still there is, if you see the curve now from the graph, you could see that this is output without supercharging, that is, and here the net output, and here the gross output. Now basically what happens is that along with increase of power output, the rate of fuel consumption is also increased. Because you have to supply more air fuel mixture, so what happens? The rate of fuel consumption also increase. But leaving aside the extremes, the fuel consumption per brake power hour does not increase, because the power increase keeps pace with the increased fuel consumption. Now the power consumed in compressing the air, apart from the increased power loss in the engine itself, has to come from the engine power itself. As I've discussed, the power will come from the engine to run the compressor for compressing the air. Thus net gain of power is obtained only after reducing this power consumption from the gross BP. But it is seen even this net power output is more than the power developed by the engine of the same size but without supercharging. Now the thing is that, now the main condition is that if the scientist now thinks that if this fuel consumption, if the power required to run the compressor can be totally minimized, so what happened? The total net gain of power can be achieved. So because there should be no power taking for running the compressor, so they thought of how to solve this problem. From their thinking, they start to think that if you see my lectures for the cooling system of an automobile, you see there is a lot of huge amount of heat passes through the exhaust system. A huge percentage of heat what is produced in the IC engine passes through the exhaust system. Now there is a huge amount of heat is there, so a huge amount of enthalpy of heat is there. So now this enthalpy is used to run a turbine. Now this enthalpy of this huge heat is used to run the turbine, and this turbine is connected to the compressor. So what happens? This heat which goes useless to the system, now what happens? This heat is utilized to run the turbine, and this turbine is connected with the compressor shaft. So what happens? The compressor now compresses it, as you could see. Now, how does turbocharged engine operates? Now we see that this is the compressor I've told in supercharged engine, the power required to compress and to send more power to increase the volumetric efficiency, we require a compressor. Now this compressor is taking power from the engine itself. If it's taking power from the engine itself, ultimately what gain we are getting is not achieved what we are thinking. So we thought of something, that the engineers and scientists thought of something, so that the exhaust system, that the exhaust gases which are going out consist of a huge amount of heat and a huge amount of enthalpy. Now the thing is that the exhaust gas the exhaust gas which is passing out of the cylinder. You see this is the blue color, the exhaust gas which is passing out of the cylinder. So as the exhaust gas passes out of the cylinder, what happens, some portion of the exhaust gas is used to run a turbine, is used to move a turbine, because there is a lot of enthalpy or useful work is there. So this useful work is utilized to run this turbine. So once it runs this turbine with a high speed, it comes out, it again comes out, and this is again comes out to the exhaust system. Now this, as it runs the turbine, this turbine has a common shaft with another turbine. So as it becomes integral with this, so as the same speed as it runs this turbine, it will run the same speed the compressor turbine. Now this compressor turbine, what happens, the air fuel mixtures entering it here the pictorial view of the compressors are shown. The compressor run by the compressed air is integral with the compressor which is used to compress the air of the inlet air. It is shown in this diagram. It, and what happens, it raises the as it compresses, it raises both the pressure and the temperature. Now an intercooler is required to cool the air fuel mixture, because if it is not cool the air fuel mixture, so it could reach the flash point at anywhere at the hot spot, it could catch fire. For that reason, the intercooler is used to reduce the temperature of the air fuel mixture. Now what happens, this air fuel mixture now enters and passes to the inlet valve. Now this air fuel mixture is not the normally aspirated air fuel mixture. It's a huge amount, a huge volume of air fuel mixture is now pumped the thing with the help of this compressor. But the main advantage of using is that this compressor is totally run by the exhaust system. So that means no power is taken from the engine. So this component is of the engine, this component is of the super turbocharger, and this component of the air fuel mixture entrance. So this is the dotted component indicates the component of the engine, and this component, the dotted component, indicates the turbocharged unit, and the right side is the air fuel unit. Now important thing is that here it does not require a single power to be utilized from the engine. Only it utilizes the exhaust gas, which goes out to the environment. That is a useful work which is lost to the environment. So this useful work, this huge power from the exhaust is used to run it. It is doing some advantage, that is getting an advantage from it. It runs the turbine of the it runs the turbine, and as it runs the turbine, it runs the turbine of the compressor also, because it's their integral. So what happens, it compresses and sends more volume of air and fuel to this engine. So now from this we could say that yes, obviously turbocharged engine gives a huge amount of power. If you require a huge amount of power, if you are a very much thrust of power, you can go for a turbocharged engine. But at the same time, some amount of more amount of fuel is also lost, because as you are throwing more amount of air fuel mixture, the more amount of fuel is also going. So when you reach a very peak power is required, then you must go for the turbocharged engine. So that is all up to the normal difference between a turbocharged engine and a normal aspirated engine. Lecture, please put a thumb up to it and subscribe to the channel for more videos related to engineering and to mechanical engineering and automobile engineering. Thank you. Have a good day.